In problem 2, we're going to analyze the Keynesian model. The values for the aggregate demand parameters have already been substituted into the spreadsheet that we used in problem 1. Same goes for the long-run production factors. These values have already been substituted into here. Finally, the same goes for the short-run production factors. The wages, the price of other production inputs, the supply-side tax rate have also been already substituted into the Excel spreadsheet. In the Keynesian model, in the traditional Keynesian model, the aggregate supply curve, short-run aggregate supply curve, has a slope of 0.000. In other words, no slope. So 0.00 is the slope of the short-run aggregate supply curve. Potential GDP, according to the spreadsheet, is 16.560. The short-run aggregate supply curve, has an intercept equal to 15.030. It has an aggregate demand intercept of 22.350 and a slope equal to 0.5. The addition of the MPS, which is 0.25 in this case, and the MPM, which is 0.25. In the diagram below, with short aggregate supply having no slope, in the short run, wages and prices are sticky. The short aggregate supply and the aggregate demand curve intersect at a point that's to the left of long run aggregate supply, or potential GDP. GDP is determined at that intersection. So GDP is 14.64. The price level is also determined at this equilibrium. And because the short aggregate supply curve is perfectly elastic, the price level is actually equal to the intercept of short aggregate supply. The gap in GDP and potential output is the difference between the two. So this is what GDP is, and this is what it should be if the resources in the economy are fully employed. So I'm going to copy this into Excel. So the difference, or the output gap, is a negative $1.92 trillion. So the output gap, in this case recessionary gap, is negative 1.92. So the economy is in a recessionary gap. In this situation, the Keynesian school advocates for a cut in taxes, an increase in government expenditure. So both of those are true. Down here, we see the same diagram that we saw in the Excel simulation. This is long-run aggregate supply. This is short-run aggregate supply. And this is aggregate demand. You need to label this the price level, PL, which is in thousands of dollars. And you need to label this real GDP, or Y, which is in trillions of dollars. And you can see the equilibrium, again, is to the left of long-run aggregate supply. It can be shown that the government spending multiplier in the AE simulation equals 1 divided by the MPS plus the MPM. Do you recognize this? That's actually the slope of the aggregate demand model. So the government spending multiplier in the AE simulation equals the inverse of aggregate demand's slope. The government spending multiplier in the above Keynesian model equals this because the price level is being held constant in the Keynesian model and in the aggregate expenditure simulation when fiscal policy is being analyzed. So the government spending multiplier in this case is 1 divided by MPS plus MPM. So it's equal to 1 divided by the slope of aggregate demand. And 1 divided by 0.5 is 2. So the government spending multiplier here is 2. Now, if we divide the value of the output gap, if we divide this value by this multiplier of 2, that gives us how much government expenditure needs to be raised by in order to close this output gap, in order to push aggregate demand out here to this point. So we divide the output gap in absolute value by the government spending multiplier 2. So I'm going to copy this into Excel to compute it. So government spending has to be raised by $0.96 trillion in the model above in order to get aggregate demand to intersect short-run aggregate supply and long-run aggregate supply at that point. So if we increase government spending by $0.96, we're essentially adding that to aggregate demand's intercept. So this is what the aggregate demand intercept was before the increase in government spending. So when we add this increase in government spending, we get the new intercept. I'll calculate that in Excel. So the new intercept is 23.31. Now let me show you why that's the case. So go back up to our model here. I'm going to put an equals in front of the initial value of government spending. I'm going to add to it what government spending has to be raised by. In this case, 0.96. So when I hit enter here, I'm going to increase government spending from its initial value of 3.53 to its final value of 4.49. And notice down here the gap is closed. And the intercept is 23.310, which is what we found here. So 23.310. The slope hasn't changed. It's still 0.500. Now, because that increase in government spending closed the gap, GDP is now equal to potential output. So I can just copy the value of potential output down here. So GDP now in equilibrium equals potential output. Now, because the short and aggregate supply curve is flat or perfectly inelastic, the value of the price level equals to what it was before the increase in government spending, which is the value of short and aggregate supply's intercept, 15.030. The gap is now zeroed because the increase in government spending stimulated aggregate demand to this point that corresponds to the intersection of long-run aggregate supply and short-run aggregate supply. So the gap is now 0. In the short run of the Keynesian model, aggregate demand and short-run aggregate supply can intersect at a point that is on, to the right of, or to the left of long-run aggregate supply. The Keynesian model is not concerned with the long run because we are all dead in the long run. The Keynesian model above concludes that the computed increase in government expenditure has no effect on the price level, raises GDP, and lowers unemployment. Because unemployment was high, greater than the natural rate here, but equal to the natural rate here. I'm going to check my work and we should get everything correct. And we get everything correct.